Hi my dear students, welcome to one more amazing session from Infinity Learn. This is Suresh, faculty of chemistry. How are you all doing? So आज हम चर्चा करने वाले हैं so board से NEET तक electrochemistry in one shot. So most of the cases we are going to discuss this in today as a part 1 and the next session is going to be the part 2. How are you all doing? Hi Sonali Gupe and Surya Pratap. Radhe Radhe. Betu, I think it is Betu. Anush from Madhya Pradesh, right? So those students, this particular electrochemistry chapter gives you definitely 2 questions from the NEET examination, and boards, as you know, it is going to be a long answer type question. So please stay tuned throughout the class and enjoy the class, and granular level from 0 level I am going to give it, and this electrochemistry is linked to directly to all the parameters and many things in the physical chemistry as well as inorganic chemistry. If you see in the D and F block elements, E naught values are very important. Based on this E naught values on electrochemical series, and these are all the applications we are going to discuss. So why late? And please like the session, share with your friends and subscribe to Infinity Learn NEET YouTube channel. बच्चों, and at the test में marks भी नहीं आ रहे, अरे practice करेंगे तो आएगा. And this is 2026 and we are coming up with electrochemistry, a new topic, and new year means new chances. Happy New Year to you all. So in the electrochemistry, what are the major topics that you are going to discuss? In the electrochemistry, we will be discussing about electrochemical series and Kohlrausch law, conductance, and electrochemical cells and electrolytic cells and batteries and corrosion, and these are the various topics that you are going to see. And before going for directly, I just want to happy new year, and before going to the class I want to talk about the basis of electrochemistry is a redox reaction. So I said this is the topic I want to discuss right from the basics, connecting to the 11th standard and the 12th standard. And आज का session है ना, and it is important for those studying in the 12th as well in the board and droppers को NEET के लिए भी. And dear students, stay tuned. What is a redox reaction? Redox reaction is a basis, and we are going to see various terminology. So a redox reaction is a type of chemical reaction in which oxidation and reduction takes place simultaneously. Beta. It involves transfer of electrons. So during a chemical reaction, one compound can give electron, another compound can take electron. Loss of electron is an oxidation and gain of electron is a reduction, right? So Betu, come on. So when we dip a copper wire in aqueous solution of silver nitrate, so what you are going to experience? Copper plus silver nitrate gives us copper nitrate, and silver is deposited. So in this copper and silver place, copper is getting oxidized and silver is getting reduced, and you can see the change that can happen like this, and very good illustrations are shown here. So a copper wire I want to put in the silver nitrate solution. So what will happen? There is a redox change. It was my birthday yesterday. Betu, God bless you. 2026 is going to be. So I want to give you 2 blessings, 3 blessings. So 2 greetings and 1 blessing. Happy New Year, greeting number 1, and happy birthday, greeting number 2, and all the best and God bless you for NEET to 2026. So fine. And those students, if you have any auspicious day, you can use the chat box and you can interact with me, and academic interactions are going to be super promoted here, right? So here when copper wire is put in the silver nitrate, so what happened? There is मेरे G mains भी आ रहे हैं 21st से. All the best Anuj. Okay, all the best Anuj. So the change can happen. The silver metal is deposited on the copper wire. So this change is experimentally seen like this. And what is this? In the reduction change and oxidation change, silver nitrate and the copper it gives rise copper nitrate and silver, and here copper is getting oxidized. Increase in the oxidation number is called oxidation, and decrease in the oxidation number is called reduction. Silver is reduced and copper is oxidized. So this is an electrochemical phenomena. Definitely we will be discussing paper in the JEE channel. Okay, not in this channel, in the JEE channel we will be discussing. So in this redox change, the Ag plus is converted into Ag, zero oxidation state, it is a reduction process beta. Copper zero oxidation state is converted to copper 2 plus is going to be an oxidation process. And bacho, in the redox reaction, here I said silver nitrate contains silver plus is converted into silver, and copper metal is converted into copper nitrate, mean to say copper 2 plus, it is an oxidation. Similarly, when iron rod is placed in water, rusting of iron takes place. So rusting of iron is an electrochemical phenomena that you can see here. Fe is converted into Fe2 plus. So this is there. Rusting of iron is an electrochemical phenomena. So justify. So it is going to be board's question and assertion and reasoning. इसमें आनोडिक रिएक्शन क्या होगा, कैथोडिक रिएक्शन क्या होगा, सब दिखाना चाहिए. सो H plus present in this oxygen combines to gives rise H2O. So ये दोनों मिलके Fe2O3.XH2O होगा. This is going to be redox reaction, right beta? And also you see iron kept in the water gives rise a rust you can see, and also you can see this is an oxidation. Oxidation is a process gain of electron, or in the process of electron transfer we can say it is a process that takes loss of electron is called an oxidation, and reduction is also the reverse and complementary process. So example, zinc loses electron is going to be zinc 2 plus is an oxidation, and increase in the oxidation number is called oxidation, decrease in the oxidation number is called a reduction. And you can see copper 2 plus takes an electron to gives rise a copper, and gain of electron is going to be a reduction. Here zinc is reduced and zinc is oxidized and copper is reduced. Any doubt? Dear children, if you have any doubt, please let me know. It is going to be super awesome concept. And let us see a redox reaction. So the reaction in which both oxidation and a reduction takes place simultaneously is called as a redox reaction. इसमें होगा आपको zinc and hydrogen. So you are going to get zinc and copper. You are going to get zinc copper couple. Zinc is oxidized and copper is reduced. H2 plus O2, and here to form H2O. And I want to say my question is, मेरे बचपन से एक ही question है. Why zinc is getting oxidized? Why copper is getting reduced? If you question this in your mind, you are in a track and you are understanding electrochemistry so nicely, right? So don't worry, stay tuned in the class. I am going to explain why zinc is oxidized and why copper is reduced. So it's a relative phenomena. Any metal has a tendency to lose or gain electron, and the relative tendency to lose or relative tendency to gain makes the difference between these two. To study that, we have electrochemistry. In that electrochemistry, we are going to see this fact in the electrochemical series. So bacho, enjoy. Really awesome slides I made it here, and you are going to see very good information right from scratch level. And you can, if you attend today's class, you can do the best in boards as well as NEET examination. So come on Betu, fine, hope you are understanding. Any doubt? Now moving ahead, here what is an N factor? जब N factor देखते हैं ना, डर लगता है आपको, right? You have seen in the normality, you have seen in the redox reaction, we are calling this N factor from the redox reaction in the grade 12, grade 11 into the electrochemistry. Definitely it is going to be useful to you. It is defined as the change in oxidation state per molecule. It is also known as a valency factor. अगर सोडियम एक इलेक्ट्रॉन लूज करके सोडियम प्लस बनेगा, so the number of electrons lost or gained in a redox change is called n factor. So ये सोडियम का हिसाब से you are going to see the change in the oxidation state is 1. So you can say n factor is 1. Not only this, so many factors I just want to discuss it here. Zinc loses 2 electrons. So change in the oxidation state is going to be just 2. So for this oxidation process, n is equal to 2. And copper takes 2 electrons. So this is the reduction process. For this reduction process, n factor is going to be 2. And when this oxidation and reduction are coupled, you have to see the balanced version of the n factor. That is also very important. There you are going to see an example. Spontaneous redox reaction hota hai kya? So a spontaneous redox reaction is very important. जैसे आपको galvanic cell में निकलेगा. In this redox reaction that favors the formation of a product at a given conditions is said to be a spontaneous. जिस condition में delta G negative होगा वो तो ये spontaneous होगा. Right? Delta G 0 होगा तो क्या होगा? Equilibrium. Delta G negative होना तो spontaneous, delta G positive होगा तो non-spontaneous. So spontaneous redox reaction can be used to produce electricity. So a cell in which spontaneous redox reactions takes place, which drives the electrons to generate, and that drives the electron motive force, is said to be electrochemical cell or galvanic cell. And we will see this galvanic cell. This is a redox galvanic cell. And when you talk about this is your zinc, metal is dipped in zinc sulfate aqueous solution. And when you talk about here, it is a copper metal is immersed in copper sulfate solution. ये दोनों मिलके एक salt bridge connect करके लगा हुआ. So what happens? They have to physically separate it. So उसमें zinc जो है ना, zinc is going to lose electron to give us zinc 2 place and 2 electrons, and those 2 electrons are coming in this way, in this way, in this way, and it is moving and reaching to the copper, and this copper 2 plus is already present in this copper sulfate, takes those 2 electrons and gives us a copper metal. So redox reaction taking place. उसमें oxidation होगा and उसमें reduction होगा. Understand? This is what is called spontaneous redox reaction. Making the move, driving force is electron motive force. So electron move करने के लिए एक chemical energy, electrical energy बन रहे हैं. यही से आपका spontaneous redox reaction, this is called electrochemical galvanic cell or Daniell cells. So non-spontaneous में कुछ नहीं होगा. So the non-spontaneous reverse the process of the redox reaction. Electricity can be used to make the spontaneous reaction to take place together. So electroplating में ऐसा होगा. I will tell you here. Galvanic cell delta G is negative, perfect, and electrolytic cell, electrolysis of water, whatever it is going to be, delta G is going to be positive. A reaction spontaneous, आगे नहीं बढ़ेगा. So ये आगे बढ़ने के लिए external force चाहिए, that is used external DC for that. And that is very important, and we come to know what is a spontaneous and non-spontaneous. You know, it is going to be here. If you take a zinc and a copper, you are going to get plus 1.1 volt, plus 1.1 volt. So how this voltage is coming, every point I just want to mention here by using all the relevant content here. Electrochemistry. Now we are into the electrochemistry. It is the area of chemistry concerned with the interconversion of chemical energy into the electrical energy and electrical energy into the chemical energy. So various examples are there. As you know, purification of aluminum. We use the most abundant metal on the earth. So we purify it. Working of batteries. Everybody is fascinating to enjoy EV vehicles. आजकल EV vehicles का जमान ज़्यादा चल रहा है ना. Okay. So working of batteries. So EV vehicle battery में चलता. Without mobile phone, the day cannot be proceeded. So that is also the important one. And fuel cells, rockets, spaceships and everything. Electrochemistry is one of our life. And here electrochemical cell, we'll talk about electrochemical cell is of two types, galvanic cell and electrolytic cell. बच्चों galvanic cell में क्या होगा, chemical energy is converted into electrical energy. Here electrolytic cell में electrical energy is converted into chemical energy. That is the basic difference I just want to say. But ये जो process है ना, delta G is going to be negative beta, it's a spontaneous. And here जो process है ना, delta G is going to be positive, it is going to be non-spontaneous. समझ में आ रही है क्या? अगर कुछ doubt है ना तो जल्दी पूछना. Moving ahead, here look at this galvanic cell. A galvanic cell is an electrochemical cell which uses a spontaneous chemical reaction to produce electrical energy. And this electrical energy, it is also known as a voltaic cell. Sometimes you say it is a Daniell cell, galvanic cell, electrochemical cell, right? So example, you can say it's a batteries, automobiles who have fundamental mechanism, chemical energy is used to convert it to electrical energy. And talking about, let us take here zinc metal is immersed in zinc sulfate, copper metal is immersed in copper sulfate. What are the changes you can see? And the mass of the zinc is decreased and the mass of the copper is increased. So it is connected to a circuit and there is something called salt bridge, आगे आपको दिखाने वाला है. And in this, so electrolytic cell, this is a cell where electrical energy is converted into chemical energy. So we are passing electricity through an electrolytic solution and electrons will flow in the reverse way. That is a different one we are going to see after a few sessions, talking about the working principles of the galvanic cell. So zinc rod, it acts as an anode. So how do you say anode? So anode is the electrode where oxidation takes place, and the copper is acting as a cathode. And what is this cathode? The electrode at which reduction takes place. Don't say always anode as a negative charge and the cathode as a positive charge. इलेक्ट्रोकेमिकल सेल में ये चार्ज का जो साइन है ना, ये उल्टा दिखता. बट फंडामेंटली अकॉर्डिंग टू IUPAC and anti-examination in the NEET, NCRT, whatever, we have to follow a rule like a cathode is an electrode where reduction takes place and anode is an electrode where oxidation takes place. ये बहुत important चीज़ का है बच्चों. And zinc is immersed and zinc is immersed in zinc sulfate solution, copper is immersed in copper sulfate solution, and दोनों salt bridge इस्तेमाल करके connect करना है बेटा. And anode and cathode is connected by using external circuit. And you see here electrons flow from anode to cathode, from zinc to copper electrode through external circuit, and the current passes to the conventionally in the opposite direction. And let us talk about this galvanic cell. So zinc is oxidized, so zinc, mass of the zinc is decreased and copper is reduced, mass of the copper is going to be increased. So let's say working of the anode. So let us consider the left beaker in the previous example. Here zinc is a solid, is converted into zinc 2 plus aqueous plus 2 electrons. This is an oxidation. Loss of electron is called oxidation. So in this zinc rod has zinc atoms and the solution has zinc 2 plus ions, and the zinc atom oxidizes, which there is an increase in the number of zinc 2 plus. So during the working of the galvanic cell, concentration of zinc 2 plus increases. ख्याल में रखो, concentration of zinc 2 plus बढ़ते जाते हैं, है ना? And this is how it is happening. बच्चों, the diagrams is self-explanatory. जब zinc है ना, zinc is dissolving, you can see. Zinc metal is coming. So what is happening? Zinc is coming out. So zinc rod in zinc sulfate solution. Zinc atom becomes zinc 2 plus. So oxidation of zinc to zinc 2 plus ions takes place, right? Any doubt? Chemically, zinc 2 plus concentration is going to be increased. And also you see here in this electrochemical cell, so zinc is a solid and it becomes zinc 2 plus and an electrical double layer is formed here. Electrical double layer is formed. Can you see this? The terminology is important. So electrical double layer is formed, developed in the system. A potential difference is created between the rod and the solution. There is a potential difference that developed between this and this interface. So that is called electrode potential. And this electrode potential makes it zinc to lose electron relative to the copper, right? That's very important. Terminology is very important. So children, just stay tuned, and if you have any doubt in this scenario, you could ask me, and those students who are online, use chat box and discuss the doubts with me. That can give you a lot of impact in our discussion between you and me. We are rising. 2026 is going to be a new year and new chances and new hope, new examinations, and this is the point where you are going to take a turn in your life. And stay tuned, I am going to give you here working of a cathode. Cathode में क्या दिखता है बेटो? कैथोड में क्या दिखता है? कॉपर रॉड इज इंट्रोड्यूस्ड इन इमर्ज्ड इन कॉपर सल्फेट. तो उसमें क्या होगा? एक जो कॉपर 2 प्लस है ना, एंड दिस इज अ कॉपर मेटल, and the copper is going to be deposited on the surface of the copper metal. Are you getting or not? And this is what I want to say. Copper is deposited. It's a reduction, and there is a potential difference between this copper and copper 2 plus, and that is single electrode potential. Copper 2 plus become copper, and the mass of the copper increases. The mass of the copper increases. समझ में आ रहा है क्या? And these are the diagrams that can help you. Copper is deposited. See the arrow mark, you will understand how the change is coming, and simple descriptive statements are being given. And also in the overall picture, what happened to the zinc sulfate? Sulfate का क्या होगा? What happened to the copper sulfate? Sulfate का क्या होगा? So this is one is a spectator ion. We can say that concentration of sulfate is constant. Concentration of sulfate is increasing the solution is getting more and more populated with a negative charge. Due to this, when copper 2 plus want to get deposited, further they are strongly dragged by the more negative charge. So that electrical double layer developed in the system, the potential created is known as electrode potential. So there is a drag here, right? And that drag is very important. To avoid that, we have to use over potential in the electrolysis. Just move, and there is a dynamic equilibrium between the loss and the gain, the process. Always you see here, and galvanic cell, talking about the galvanic cell. So we have seen the electrochemical cell. In that it is built by 2 electrodes. Zinc rod is dipped in zinc sulfate, copper rod is dipped in copper sulfate, and it is connected by a salt bridge. What is the salt bridge? We have seen, and let us see. This is your salt bridge, and this is the fundamental construction of the galvanic cell. Bachcho, any doubt? So many students are coming and discussing so many doubts, and in the description box whatever the links that are available, you just click it and see how the things are going to be proceeded. And this is a YouTube channel, we are giving lectures for the free of cost, and please enter into our channel and enjoy, and please like this session, share with your friends and subscribe to Infinity Learn NEET YouTube channel. Bachcho, now in the galvanic cell, zinc plus copper 2 plus gives rise zinc 2 plus and copper. So the overall redox reaction includes both oxidation as well as reduction. Oxidation में क्या होगा, zinc solid is converted into zinc 2 plus by the loss of 2 electrons. जो electron zinc lost na, it is gained by copper. So that copper is going to take those 2 electrons and become a copper. So zinc rod is essentially converted into zinc 2 plus and copper is deposited. The mass of the zinc is decreased and the mass of the copper is increased. And electrode, उसमें electrode क्या होगा देखो, and this is an electrode. Electrode is the one, a metal immersed in a salt solution is called electrode. So you have two types of electrode. An electrical conductor that is used to make the contact with the non-metallic part of the circuit is known as electrode. Technically, so the statement type questions statement type questions are important. In the NEET examination, statement type questions are important. You need to have a clarity on how you are doing and what you are doing. You have two types of electrodes. Electrodes are commonly subdivided into two types. One is an anode, another one is a cathode. Let's see the difference between what is an anode. The electrode where oxidation takes place is called anode. So what are the characteristics? Oxidation takes place, so it attracts anions and it acts as a source of electrons, and in galvanic cell it is negative charged polarity. So these are the four statements are given, and these statements are related to statement 1, statement 2 types questions. So journey in the NEET examination. So in the session bar NEET बोल के, my dear doctors, I am telling you, studying these statements at the granular level and admitting the statement is very important. When in the examination जब statement आता है ना, actually the meaning of the statement आपको पता होना चाहिए. That's why we are giving emphasis on more theory oriented questions. Of course, आज का सेशन में न्यूमेरिकल्स भी आना है, and I will tell you how these numericals are being done. So coming to the cathode, it is the electrode which reduction takes place. Say an example, copper takes 2 electron, become a copper 2 plus. मेरे ख्याल में है कि अरे जब जिंक है ना, जिंक 2 प्लस है ना, सो कभी जिंक 2 प्लस जिंक नहीं होगा जब zinc, when it is with copper, zinc loses electron. Copper, when it is with zinc, it takes electron. And copper, when it is with silver, it loses electron. So you will come to know in this electrochemical series. So characteristics of a cathode: reduction takes place and it attracts cations. It acts as a sink of electrons. In the galvanic cell, of course, it's a positive charged polarity. Polarity changes for electrolytic cells. That's also very important. बच्चों समझ में रहे क्या? अगर कुछ डाउट है ना तो आप पूछना सीधा. बेतो, come on, say hi. Anush. Moving ahead, So many things. Galvanic cells, we have half cells, metallic wire, salt bridge. Let us take a construction. We need three components. We need three components. Let us see what are the half cell. Half cell means we are talking about a redox reaction. उसमें ऑक्सीडेशन जो ऑक्सीडेशन पार्ट ऑफ द रिएक्शन एक सेल में अलग रखना, रिडक्शन पार्ट ऑफ द सेल अलग रखना, दैट इज कॉल्ड हाफ रिएक्शन. Anode, zinc anodic half cell, copper cathodic half cell. And in this half cells we have the example zinc 2 plus loss of 2 electrons, and the copper 2 plus takes 2 electron become a copper, that is a reduction half cell. And these two half cells are constructed and connected through the external wire which is connected from the anode to cathode, and we have a salt bridge. What is a salt bridge? And it is a U-shaped inverted tube, and it is filled with inert solvents like potassium chloride, and it is solidified with the paste of agar-agar gel. Okay, a paste of agar-agar gel. And let us see here, this is the salt bridge. And why it is pasted? Because the जो salt होता है ना उसमें, and salt नीचे गिरता, but it need to be a conductor. Actually this salt bridge completes the circuit and physically separate anode and cathode, and it prevent the charge accumulation with the anode and the cathode. So these are the various points I need to talk about this. Okay, any doubt, bacho? Right. So let's talk about need for salt bridge. So again NEET examination में statement जैसे silent and sensitive statement बना के आपका NEET में options में दे देते हैं. So in that, if the electrodes are salt bridge required to maintain the electrical conductivity and physically separates, and it physically separates anode and cathode, and it is going to complete the total circuit, and it is going to prevent liquid junction potential. And what happened here? Look at this. Zinc loses electron, becomes zinc 2 plus, and these two electrons are going in this way. So that copper 2 plus takes 2 electron become a copper. So what happened? ऐसे जैसे zinc 2 plus है ना, positive charge बढ़ता जाता है, and copper 2 plus is decreasing. So what happened if you use a KCl to neutralize this? Cl minus will come this way and potassium plus it come this way, right? So to maintain the electrical neutrality in the either cells, that is the need of salt bridge. That's very, very important. So in general, the salt bridge electrolyte contains a migration towards the cathode and anode. So you have anode and a cathode, and you have the salt bridge and the salt. We have ammonium nitrate, potassium chloride, and inert solutes you have to take. So condition, ionic mobility of the cation should be nearly equal to ionic mobility of the anion. So this is the condition to use the salt in the salt bridge. And based on this, you can have a question in this NEET. And also the electrolyte should consist of cation and anion having the same mobility. ये जो point आपको देना चाहता हूँ. Right, beta? Sonali, right? And they should not react with the electrode or electrolyte, and the electrolyte should not get oxidized or reduced. Okay? So there should be chemically inert. Which of the following is a true statement? So जैसा questions NEET में आने के संभावना ज़्यादा होगा. Got it? Any doubt? Please ask us. Hi Krishan. Hi Kishan. Hello. You came late or what? I want you guys, those who are attending the classes, please share this session with your friends. आज session में हम आग लग रहे हैं, right? Now, this is the criteria. Construction of galvanic cell, we already seen that. And in this, zinc is oxidized, and zinc oxidizes to become zinc 2 plus, and these two electrons, these electrons are given to the external circuit and it is coming to the anode, so that copper 2 plus is going to take those two electrons, become a copper, and this is a salt bridge. And here this is anode, oxidation takes place, and this is cathode and the reduction takes place. Mass of the zinc decreases and mass of the copper increases. Christian carry. So which is, we are discussing the same points in this current class here. And moving ahead, characteristics of an anode and characteristics of a cathode. Every point I am discussing here. Oxidation takes place at the anode, and it acts as a source of electrons. It is a negative polarity. Characteristics of the cathode, it's vice versa. Do not remember the polarity. Danger. If you remember the polarity, you're gone. Because electrolytic cell में वो अलग होता है. Okay, it's not always true. It is true as far as the galvanic cell is construction is concerned. Okay, moving ahead here, salt bridge. Salt bridge is a U-shaped tube. We had a discussion and everything, it is done here, right? And a terminology called zeta potential, excess point का है. What is this zeta potential? Need for salt bridge. Oxidation takes place at anode and reduction takes place at cathode, है ना? Right. So अगर oxidation reduction का हिसाब से, so cathode में electrons accumulate कर रहे हैं and anode में positive charge accumulate कर रहे हैं. So initially this increases. Zinc 2 plus का concentration anode में increase करते जाते हैं, and the solution while the sulfate concentration remain the same. ताकि क्या होगा, and the imbalance in the charge is known as zeta potential, and it pushes back from some of the zinc 2 plus to zinc. Here is equilibrium is established between zinc 2 plus to zinc, and that equilibrium, so we have to make this equilibrium in the forward direction, right? A zeta potential over टर्न करने के लिए आपका न्यूट्रलाइजेशन करना जरूरी है. एंड आई वांट टू से, सो वर्किंग ऑफ द सेल, द इक्विलिब्रियम नीड्स टू बी शिफ्टेड. नाउ द शिफ्ट ऑफ द इक्विलिब्रियम इफ यू न्यूट्रलाइज इट. ओके, सो हाउ टेक्निकली दिस पॉइंट इज बीन एक्सप्लेन्ड. सो वी नो सॉल्ट ब्रिज इसका रोल का एंड एवरीथिंग, but it is according to the NCERT it is given. Copper ions in the other solution accept the electron coming from the zinc and to form the copper atoms to get deposited. So that happen, copper 2 plus का concentration भी कम आ रहा है, positive charge का concentration कम आ रहा है, so sulfate का concentration बढ़ रहे हैं, so it has to be neutralized. So the excess of positive charge is formed. To avoid this excess of positive charge, it has to be neutralized बच्चों, right? So that neutralization is done by salt bridge. And for the continuous generation of electrical energy, here zinc 2 plus from the anodic and sulfate ions from the cathodic compartment has to be neutralized. So that is the main role of the salt bridge. What happens if a salt bridge is removed? The galvanic cell stop working. right? Here, this is the one, continuous generation will not be there, light is going to be done. जब आप salt bridge डालते हैं ना, ये चालू होगा, ये चालू होगा, right beta? And that is the important point. And if you remove the salt bridge, it is going to be stop these galvanic cell. So what happen if salt bridge is removed? So basic understanding level, I am telling you, my dear children, NEET examination is not focuses on how tough numericals you do in the examination. Rather, NEET examination is going to focus on how efficiently, what is your understanding level, what is your application orientations, and so can you understand if the same statement is given different way. Everything is important and it gives a lot of impact, just like application of salt bridge like this. So criteria of selecting salt bridge, that is very important. It should consist of cation anion having the same mobility, very important. Statement 1 and statement 2, or which of the following statement is true and which of the following statements are false, like that. It should not react with ions in the solution, should not get either oxidized or reduced at the electrodes. So these are the criteria of selecting salt bridge. And you just see in this electrode potential. What is electrode potential? जब zinc metal है ना, zinc metal zinc sulfate में डालते हैं, so you have zinc 2+. So electron का हिसाब से हमको दिखा दिया आपको, there is an interface between aqueous and this solid, and there is an interface between these two, and there is electrode potential is developed, and this is what is called a galvanic cell involves oxidation reduction at a perspective of electrodes. The ability to undergo oxidation and reduction electrodes by the atoms or ions is known as electrode potential. It is actually measured in terms of volts. If it is a single metal, it is called single metal electrode. And here at equilibrium, there is a separation of charges, right? And the experiencing the separation of charge, zinc rod and the zinc 2+ ions, and there is an interface between these two, and the electrode potential is the interface exists between these two. And equilibrium, there is a separation of charge, and depending upon the tendency of two opposite reactions. So electrode is positively or negatively charged with respect to the solution. It is at the dynamic equilibrium, and at this dynamic equilibrium, the way it is getting oxidized and reduced based on this electrode potential is of two types. So this is electrode potential. Electrode potential is defined as the electromotive force developed in a galvanic cell made with a electrode against a standard reference electrode. What is the standard reference electrode? Hydrogen reference electrode, we take it. It is denoted by E. अरे E अलग होगा, E not अलग होगा. So it could be oxidation potential, or it could be a reduction potential. So oxidation potential, the tendency of electrode to lose electrons. So जैसे आपको zinc 2+ देके 2 electron दे रहे हैं, so that is called oxidation potential. And moving ahead, we have a reduction potential. So the tendency to gain the electron, जैसा आपको copper 2+ takes 2 electron becomes a copper, that is what is called a reduction potential. Krishna Kaira, right? Betu? And talking about, so standard electrode potential, we are going to show you E naught. This naught indicates it's a standard condition. When the temperature is at 1 atm and 1 bar and 298 Kelvin, the electrode potential what you measure is called a standard electrode potential. Okay, we can easily say that oxidation reaction of A can be higher tendency to give up the electrons, and reactants get oxidized easily because the electrode potential is very high based on this 2.3 and 6 volts over here. So that is given in terms of electrochemical series. Stay tuned, I am going to tell you about this. Children, and you see B with respect to zinc, A value 6 volts, zinc का value 2.3, शायद मान के चलो, and you can say here if it is going to -5, we can say, now we can easily say oxidation reduction of B is very low and tendency to give up the electrons, and potential is very low. Now we can easily say that it is a very high tendency to get reduced, okay, then accept the electron to give the solid metal because it has a very low reduction potential. What is a oxidation potential? What is a reduction potential? Oxidation potential is the electrode potential for oxidation process. A reduction potential is a potential for the reduction process, okay, and the magnitude is going to be same. And I want to say zinc 2 plus takes 2 electron become a zinc, and E naught is going to be zinc 2 plus, and zinc is going to be minus 0.76, and this is called SRP because the process जो है ना gain of electron, so it is going to be a reduction. For the reduction, it is a reduction potential, standard reduction potential. And a process ulta कर दो, so zinc gives rise zinc 2 plus, and lose the electron becomes E naught zinc and zinc 2 plus, and it is going to be plus 0.76. This is called SOP. Why this is SOP? SOP means standard oxidation potential. This standard oxidation potential and standard reduction potential magnitude same hoga. So the magnitude of SRP is going to be magnitude of SOP. I mean to say अगर SOP वैल्यू नेगेटिव होगा तो SRP वैल्यू पॉजिटिव होगा, अगर SRP वैल्यू नेगेटिव होगा तो SOP वैल्यू पॉजिटिव होगा. So there is no rule that SRP वैल्यू हमेशा नेगेटिव होना चाहिए, ऐसे नहीं होगा. It could be negative or it could be positive. And you see case 1, various cases I want to give you. बच्चों, this is a real time depth of the subject बच्चों. So you just see various cases to understand. So the potential difference, electron potential or EMF. So electrode potential or electromotive force. So the potential difference between any two electrodes is known as electromotive force. That could be given EMF or E naught cell is equal to E naught of cathode minus E naught of anode, and this is what is called EMF. And this is cathode and anode लिया, कौन सा value देना, and you have to take the SRP values, and SRP values are supposed to be used because NCERT follows SRP values, right? According to IUPAC, it could be oxidation plus reduction or oxidation of left minus oxidation potential of right, but better you use this. And case 1, let us take 2 electrodes, मान के चलो ये होगा B होगा, that are dipped in their respective solutions. Okay, so A is going to be 3 volts, B is going to be 4 volts, and दोनों का है loss of electrons are there, loss of electrons है, oxidation potential value का इसका दिखाई दे रहे हैं. And you take And in this case, electrode A plus solution and B solution, B plus solution. So the electrons comes in this way. And also you can say, bacho, since B has a higher oxidation potential and electrons always move from the B to A. We know that O electron always flow from the high electron density to low electron density. Hope you are understanding. And also you can see cell potential. Hence electron flow takes place always. By convention, anode and oxidation half cell is placed in the left and cathode and reduction cell is taken in the right side. This is according to IUPAC. In the left hand side, anode likhna, in the RHS you have to write cathode and you have to separate anode and cathode by two vertical lines. That is given as IUPAC representation of the galvanic cell. Bacho, and in this case, now case 2. Let us say if A 3 volts and B minus 4 volts. So we can see that oxidation potential of A electrode has a positive value, but that of the B has a negative value, right? So thus B electrons has a tendency to gain electron, उसमें reverse होता है, उसमें reverse होगा. So that A solid A plus take a lose electron 3 volts, B plus takes electron 4 volts. So those students who are online, stay tuned and take a pen and paper, write along with me. So very good. This is a case 2. And I want to talk about here the reverse takes place. Electrons move from in this way. I want to say. So if we consider the SRP values, and the mathematically bigger SRP values are going to be a cathode and the mathematically smaller SRP value is going to be anode, and that gives a redox couple to construct a galvanic cell. समझ में आ रही क्या? So when the galvanic cell based question is coming, you can understand which is a cathode and which is anode, and for that it is given as a case 1 and a case 2, and these are the two cases. As a stretch, I want to give you the difference between these two, so you never miss any concept out of this, and hope you like it and take a screenshot of it, and any doubt you can just ask us, right beta? That's perfect. Now cell potential in EMF we have seen, if that is the case 1, the difference in these two values is going to be 1 volt. This, mind it, this is a hypothetical condition, and in this values 3 plus 4 is going to be 7 volts. And you have to see this particular example is given in such a way that you develop a logical approach to understand the chemistry. So simply reading 100 times an NCERT doesn't give you impact beta. So this is the work you need to do in the Infinity Land NEET YouTube channel. We are working on this. A special team is deployed how to make a student work on the NCERT. So this is an example that you can say, and I can say the reference electrode. We can say, so how do you get electrode potential? Single electrode potential, let it be standard electrode potential. So जो SRP value है, OP value, individually it is impossible for us to determine. Then how do you say, but the difference between these two electrodes can be defined. So if we want to measure a individual electrode, so we have to take a reference electrode. So reference electrode E cell calculation when both the electrodes are preferred to reduction. So E cell value, reduction potential of substance is getting reduced minus. The reduction potential of substance is oxidized. If one thing you take as a standard, then you will understand what exactly it is. So let us talk about the reference electrode, that is standard hydrogen electrode. So reference electrode, calculating the exact potential of an electrode. Consider the zinc metal is dipped in this zinc sulfate solution and zinc loses electron. So it is going to be 0.76 volts. आपको कैसे पता चलेगा at equilibrium ये 0.76 होना है कैसे? And for that we need a standard electrode. So charge separation potential difference. Okay, so reference electrode is required to define the electrode of a single electrode potential. For that you need a standard. So I can take hydrogen as the reference electrode. So we have various reference electrodes बच्चों. In that NCERT के हिसाब से एक ही reference electrode है हमारे पास. Okay, we can use that. And the electrode of known potential. The electrode of known potential can be treated as a reference electrode. Among all, most commonly used reference electrode is hydrogen electrode. This is otherwise we can say standard hydrogen electrode, she or normal hydrogen electrode. ये होता है क्या? So standard hydrogen electrode is used as a reference electrode. Thank you very much. God bless you, my dear children. And we'll see the image of the standard hydrogen electrode here. So two major types of electrode potentials are given. It could be SOP or it could be SRP. Okay, let's discuss about SOP and SRP, how it is measured. Potential electron देने के वाला है. So it is the electrode potential of oxidation of cell is known as oxidation potential. Electrode in the oxidation of reaction happens in terms of negative electrode. So you can say a metal loses electron, n number of electron gives us Mn plus, right? And another one is oxidation potential. आपको जैसे zinc वाला है, zinc is lost its electron, so zinc 2 plus बनेगा. So that when the concentration is taken as 1 molar at the standard conditions 298 Kelvin and it is at 1 bar pressure, we can say it is standard electrode potential. So in the standard electrode potential always you use E naught. The naught represents the standard state of the metal. Okay, that is very important. So an example H2O2 gives rise O2 plus 2H plus and 2 electron. This is a loss of electron का जो process है. This is what is called oxidation half, and it represents so EH2O2 and O2, and you can say zinc loses zinc 2 plus and 2 electrons, and you can say this is called yes zinc and zinc 2 plus or E naught oxidation. Better you understand. This notation can tell you whether it is taking oxidation or taking a reduction. Got it? So copper and gives us copper 2 plus. So you can write this as, and also reduction potential. It is exactly the opposite version of the oxidation potential. Are you getting or not? Now moving ahead here, so copper takes the 2 electron become a copper. You can write this as E naught of copper 2 plus is converted into copper. So this indicates it's a reduction potential, right? And its value is 0.34. My dear children, you tell me, do you have to memorize this? No value memorize it. जो भी value आपको चाहिए ये प्रॉब्लम सॉल्व करने का, ये क्वेश्चन में कुछ देने वाला है, नो वरीज. ओके, हियर दिस इज एन एग्जाम्पल, दिस इज एन एग्जाम्पल, दिस इज एन एग्जाम्पल, राइट. इसका वैल्यू है -0.76. अरे SRP वैल्यू नेगेटिव भी हो सकता, पॉजिटिव भी हो सकता, राइट. SRP वैल्यू नेगेटिव भी हो सकता, पॉजिटिव भी हो सकता. And also you can say H2O2, its values, you need not have to memorize it. Now, want to say types of electrode potential, oxidation potential versus reduction potential. आपको बोलना चाहता हूँ क्या उसमें. So, oxidation reduction potential for electrodes are equal in values, magnitude equal होता है, लेकिन अगर oxidation potential नेगेटिव होगा तो इसका रिडक्शन पोटेंशियल पॉजिटिव होना चाहिए. अगर रिडक्शन पोटेंशियल नेगेटिव होना चाहिए तो ऑक्सीडेशन पोटेंशियल पॉजिटिव होना चाहिए. दैट्स व्हाट. सो कॉपर, हियर कॉपर SRP, दिस इज SRP वैल्यू पॉजिटिव है एंड SOP वैल्यू नेगेटिव है. गॉट माय पॉइंट? क्लियर? एनी डाउट? दैट्स वंडरफुल. इलेक्ट्रोकेमिस्ट्री में ये फंडामेंटल्स काफी इंपॉर्टेंट है. जागृति यादव, व्हाट इज दिस VBX CCCCC? ओके बच्चों, no. Okay, be careful here. So in this copper and zinc, so predicting the spontaneous reaction occurring at the electrode. Simple, it's a simple thing I want to say. You have E0 cell is equal to E0 of SRP of cathode minus E0 of SRP of anode. ओके, अगर E0 वैल्यू पॉजिटिव होगा तो ये रिएक्शन स्पॉन्टेनियस बनेगा. फाइन. Hi Rashik. Well, so that is the same thing. Copper 2 plus takes electron, gives us copper. इसका value plus 3.4 का, and copper in reverse करके ये value minus 0.34 बनेगा. जागृति यादव, I taken your name and I am expecting when I say your name, you need to ask me a doubt. That is the deal. Any student name I can take in the chat box if you ask a doubt. Fine. Now let us say the predicting the spontaneity. So zinc का minus 0.76 है and the copper का plus 0.31 का होगा बेटा. So as E0 value, if you want to calculate here, E0 value, okay, E0 cell is equal to E0 of cathode copper 2 plus and copper minus E0 of zinc 2 plus and the zinc. इसका वैल्यू आप प्लस 0.34 साइन का साथ आप लिखना है, सो दैट इट इज गोइंग टू प्लस 1.1 वोल्ट. सो एज दिस वैल्यू इज गोइंग टू बी प्लस, you are going to experience this into a spontaneous, that oxidation of zinc is a spontaneous process with respect to the copper. Cell potential EMF, that's what I was discussing here. So IUPAC convention, according to IUPAC convention, cathode should be written on the right side, anode should be written LHS or left side. And you see here the same thing I wanted to give you, we already did this, right? So sign of cell potential, that's always the sign of the cell potential tells us the direction in which the reaction must shift its equilibrium. Very happy and be happy. Okay, Rashik, skibidi, what is, I don't know what is skibidi. Right. So, if the electrode potential of both half cells are the same, okay, either both half cells have the same oxidation potential but both have the same reduction potential, then the overall cell potential becomes 0. Both cancel hoga na. Rise up. Okay. And the reaction you see here, if zinc 2 plus and zinc minus 0.6, the copper, it is going to be minus 0.34, and you are going to see the difference between these two is going to be 1.1. So, if you connect copper and zinc, it is going to be a zinc is an anode and a copper is a cathode, and between these two a galvanic cell you can construct by using a external wire and a salt bridge. Okay, जागृति यादव कुछ बोलना चाहता हो क्या? That's good. So, if we want to take in the reverse side, it is going to be opposite way. Right. Thank you very much, Jagriti. And we can say here cell potential. This is the condition where E naught cell is going to be 0. The overall reaction is at equilibrium, bacho. If E naught cell is going to be positive, the reaction is going to be spontaneous. If the E naught cell is going to be negative, the reaction is going to be non-spontaneous. So, the magnitude of the cell potential is a measure of the driving force. I am fine, thank you, thank you. God bless you. So, 2026 means it is a new chance, okay, new pathways, okay, new avenues and new examinations, new results. So, new life. So, larger the value of cell potential, faster is the reaction to reach the equilibrium. Okay, बच्चों, and आपको E naught जो cell है ना, this is E naught cell is equal to E naught of cathode and E naught of anode. Okay, बच्चों, here I want to say you stay tuned for exactly 5 minutes break so that it's a long marathon session, and we will be having a मुझे इंग्लिश नहीं आते हैं, okay, फिर वापस आना 5 मिनट ब्रेक लेके, एंड आई विल एक्सप्लेन यू द नर्न्स्ट इक्वेशन एंड electrochemical cells and electrochemical series and everything. So stay tuned बच्चों, सिर्फ 5 मिनट का ब्रेक है, तैयार है, रेडी बेटो, फाइन. सो मैं यहां शुरू कर देता हूं. But we know that SRP of substance is getting oxidized is equal to negative SOP of substance is getting oxidized. मेरा आवाज सुनाई दे रही क्या बेटा? If you have any doubts, please let me know. E0 cell is equal to SRP of substance getting reduced minus SOP of substance getting oxidized. E0 cell can be calculated as SRP of substance getting reduced plus SOP of substance getting oxidized. I mean to say E0 cell is equal to E0 of reduction plus E0 of oxidation. You know, these are the various systems you need to know. Which of the following is true? Which of the following is not true? Kind of things can be asked in the NEET examination. Anush, Betu, okay, Jagriti Yadav and Rashik. Any doubts you can ask me if you have any doubts. मेरा आवाज सुनाई दे रहा है क्या बेटा? Right. And also few cases E0 cell calculation is given follows. Case 1. Consider two half cells, standard oxidation potential 3 volts and -5. I think we discussed this. Okay, let us directly go into the thermodynamics of the cell. It's very important. Shashwat, Shashwat, you will be getting a question directly from thermodynamics of the cell. So delta G का हिसाब से. So what is the thermodynamics feasibility of the cell? EMF refers to the vigor which the cell works. That is given in terms of delta G and cell potential EMF. How is delta G is related to the spontaneity? We know that delta G is equal to delta H minus T delta S. You have delta G, it could be positive, delta G it could be negative, delta G is going to be 0. Delta G is going to be negative, the process is said to be spontaneity. And delta G is 0, it is a equilibrium, delta G is going to be positive, that is going to be non-spontaneous. In the electrochemical point of view, we can write this as delta G is equal to minus N of E0 cell. So, delta G is equal to minus NF E0 cell. So what is N? Number of electrons that are involved in the redox change, and F is the 1 Faraday. So 1 Faraday is equal to the charge carried by 1 mole of the electrons, 96,500 coulombs. And E0. See me? Please connect. Can you see me, Bacho? Yeah. Since the electrochemical change, the work must be electrical work, and delta G magnitude is equal to work done in electrical work. Yeah, thank you very much. And the electrical work is given as a Q into E0 cell. Q is the total charge. For 1 mole of the charge, if we say 96,500 coulombs. So that is equal to 1 Faraday. The charge carried by 1 mole of electron is going to be 96,500 coulombs. Bacho. Yeah. Shashwat. So getting All India rank 1, definitely. We hope definitely you may get all India rank 1. Q is equal to total number of electrons and charge of electron. For 1 mole of electron, it is going to be Faraday constant. So that is given as kitna diya na? 96,500 coulombs. ख्याल में रखो, ये वैल्यू आपका ख्याल में रखना. 96,530, roughly 96,500 ले सकते हैं आप. Sashwat, right, Jagriti Yadav. Very good. We are all working together for your betterment. Now, let us see here. Charge on 1 electron is equal to 1.6 into 10 power minus 19 coulombs. है ना? charge on 1 mole of electron, that is 1.6 into 10 power minus 19 into Avogadro number, that is 6.022 into 10 to the power of 23. सब मिलके आपको मिलेगा 96,487 एंड मान के चलो 96,500 होगा, right? This is Faraday's constant. So charge on 1 mole of electron, you can say it is convenient for us to take in the calculations. Any doubt? Sashwat, any doubt? Fine. Now moving ahead, Gibbs free energy change. So concept of delta G. So delta G is equal to minus NFE cell. N is the number of electrons involved in the redox change. And delta G and delta G naught. A naught kya? It is at any condition. It is at a standard condition. At standard condition, it is going to be minus N of E naught cell. E cell क्या होगा? E naught cell क्या होगा? E naught cell जब concentration 1 mole per liter and the temperature 298 Kelvin and the pressure 1 bar. And E cell, the concentration could be anything beta. And so where E naught cell is greater than 0, positive, and delta G is going to be negative, is going to be negative means it signifies the electrochemical change is spontaneous, a cell works, galvanic cell reaction आगे बढ़ना है, right? And also you see E naught is an intensive property. So we are in thermodynamics. We are in thermodynamics. E naught value is intensive property. You cannot add them. You cannot add them. So mass independent, intensive property का मतलब mass independent. So multiply divide the cell reaction by any number, standard electrode potential value would not change. Standard electrode potential value would not change. मैं क्या बोलना चाहता हूँ? Copper 2 plus takes 2 electron, gives rise to copper. So E naught value is going to be plus 0.34. है ना? But delta G is going to be extensive property beta. So half copper 2 plus take electron and half copper बन गया. So E naught value फिर भी plus 3.4. Arre. So this is meaning of intensive property beta. So we are learning electrochemistry, we are learning chemical kinetics, we are learning equilibrium, we are applying thermodynamics, we are applying equilibrium, we are applying many things in this electrochemistry. Yeah, it will also be 0.34. I really accept your answer. So standard electrode potential would not change. So understanding, studying electrochemistry is different. You open YouTube channel, hundreds of lectures are available from different YouTube channels. But my intention from the Infinity Learn YouTube channel is to say, be firm in granular level, logical oriented version of this electrochemistry. So definitely it can help you. Fine. So it is not like a glamorous, chilling type of classes. So my intention and my version of delivering lectures is the impact in the student mind should give to crack the NEET examination. Delta G become half. अगर आधा कर सकते हैं तो मिलेगा. So I will tell you how it could be. It is an intensive property. You can't add or you can't divide, multiply. Now concentration, calculation of unknown electrode potential का क्या होगा? So let us consider 3 half cells. Let us consider 3 half cells. उसमें iron 3 plus iron 2 plus X. So I want to say here, let us see, iron 3 plus is giving rise to iron 2 plus and iron, and here number of electrons is said to be n1, it is going to be n2, and it wanted to take into the n3 number of electrons. Let us say iron we have 3 electrons in this conversion. And मैं क्या बोलना चाहता हूँ, here let us say electrode potential in this first process is going to be E1, electrode potential first process is going to be E2, electrode potential for third process is going to be E3. You want to say E03 is equal to E01 plus E02. You want to do it like this? It is absolutely not correct. Rather, you can say delta G is going to be 3 and delta G is going to be 1, delta G is going to be 2. We can say delta G naught 3 is equal to delta G naught 1 plus delta G naught 2. ये परमिटेड है, परमिट नहीं है. एग्जैक्टली अगर n वैल्यू सेम होगा तो आप कर सकते हैं. सो दिस इज द वर्शन आई वांट टू से 3 to 2 x, 2 to 1 y, and 3 to 1 is going to be how much? And this is a model of the question based on this NEET examination. टाइटल का पहले AIPMT था, and we have a couple of questions based on this concept. I have seen at least 4 or 5 times based on this concept, both medical entrance examination and engineering entrance examination and even CBSE examination based on this concept. Several times I have seen. Nomenclature could be same. अभी जो NEET है and previously it was AIPMT था, है ना, and IITG था, and now it is IITG, previously IIT and AIEEE kind of things. Okay, let it be. Here first half cell, Fe3 plus takes electron Fe2 plus, N1 is equal to 1, E1 is equal to X. And Fe2 plus takes 2 electron, Fe, N2 value is going to be 2 and electrode potential is going to be Y. आपका पूछने वाले हैं Fe3 plus is taking 3 electron gives us Fe and 3 is equal to 3 and E3 is going to be how much? Third half cell. And I simply take these values, delta G3 is equal to delta G1 plus delta G2. Okay, and by using this, and everything is self-explanatory. Hi Vani, Anmol, Prema, Vani. Hope you're understanding. You came late. Bacho, you can hear me? Anmol. Now delta G1 plus delta G2 is equal to delta G3, and delta is a state function. You can add and you can subtract and you can multiply, you can divide it. Now since the reaction 3 can be obtained by the equation 1 and 2 as like this. Okay, right, you can hear me? Any doubt? And also minus NF E01 minus NF N2 E02 minus N3 E02. So this has to be calculated. F काट दो, F काट दो, F काट दो. Now that is what? Delta G is a state function. From there you can do it like this. So E3 is equal to N1 E01 plus N2 E02 upon N3. So delta E03 is equal to 1 into X plus 2 into Y by 3. So it's a simple x plus 2y by 3. So this is your answer. Got it? Shashwat, any doubt? Anmol Premavani? So super important model it is. Super important model, है ना? Moving ahead. So even in the copper, so boards and needs, you can get the same. So we are running this one shot series, can be helpful for both boards as well as NEET examination code. So here you can say half cells are given. So copper to place copper 0.33 volts, and you are asked to get copper to copper. So copper plus 1 to copper 2 plus minus 0.153. So we need to calculate this out, and this has to be find, and on calculation 0.521 मिला. अगर कुछ डाउट आने तो जल्दी पूछना. Direct questions you may get in the boards and the NEET examination as well. And the entire session notes you are going to get in the Telegram channel. Entire session notes you are going to get from the Telegram channel. Okay. Right. And also, yes, now you study something, you will get some other thing in the examination. It is given manganese plus 2 and permanganate minus 0.51 and manganese dioxide Mn2 plus 0.13, and you are asked to calculate MnO4 minus permanganate to conversion to manganate, so manganese dioxide. इसका E0 value कितना होगा in acidic medium, right? So it is given as a 0.51 and it is given as a 0.52, 0.13 plus 0.13. So you have to balance this. However you balance it or down balance it, this value कुछ बदलते नहीं. Okay. Now to balance this, you will come to know the number of electrons, right? So it is going to be Mn2 plus 4H2O gives us MnO4 minus. So you need to solve the questions by using actual given data. So the metal atom involved Mn is already balanced in this first. In the second one, so the balance the charge by adding sufficient number of electrons, so that you are going to get Mn2 plus 4H2O gives us MnO4 minus plus 8H plus 5 electrons. Okay. And E value is going to be minus 0.51, right? And there you have to take the number of electrons, 5 electrons mila. Okay. And in that MnO2 Mn2 plus, so plus 4 is getting plus 2, uska 2 electrons hona chahiye. So that when you solve this, yes, on doing so, you are going to get the overall balanced reaction is going to be, you are asked to calculate MnO4 minus 2 MnO4, it is going to be plus 7 and it is going to be plus 4 and value 3 hona chahiye isko, right? So on doing so, you are going to get balancing the redox reactions is the key point what you learned in this grade 11. Fine. And in that you see here how it is going to be delta G3 is equal to minus delta G1 minus delta G2 minus N of E3 minus N of E1 minus of minus N2 E03. all the values they kept it now. Put this value as 5 electrons is the first reaction, 2 electrons is the second reaction, 3 electrons is the required third reaction. Put all the values, you are going to get E03 as 1.69 volts positive. And this is how, if you get a most difficult question in the NEET examination, this could be, you need not have to write the entire working, rather this is the key point. This is the key point. When you see here the question, I want to go back from here to here, n is equal to 5 because plus 7 it is plus 2, and from here to here plus 4 and plus 2 it is going to be 3, and here it is going to be plus 7 plus 4 and it is going to be 3. So the same values I interpreted here, the same values I interpreted here, okay, yeah, plus 2 and plus 4, right, here it is going to be 2. The same values I interpreted here, and I am going to get the simplest way of this. You can do the best once you learn all these things, right? So, like that, so many questions are there. Electrochemical series activity, and this gives a lot of impact on overall study of chemistry. Electrochemical series or activity series. If two metals are given, which is more reactive as compared to the other metal, you can say based on this electrochemical series. So, observations in electrochemical series. You see, the electrochemical series is constructed in such a way that the standard electrode potential is connected, the standard electrode is connected to the normal hydrogen electrode, and the SRP value got it. Once you get the SRP value, it is tabulated to form a table that is called electrochemical series. So, the electrochemical series is referred to as, it is referred to as activity series. Okay, so in this electrochemical series, what are the things you will know? I want to see. Electrochemical series, a negative E0 signifies high tendency to get oxidized, and that has the redox couples is a strongest reducing agent than hydrogen, and a positive value signifies high tendency to get reduced. So, that redox couple is a stronger reducing agent than hydrogen. So, this is the activity series, this is the activity series, and this activity series I want to say hydrogen is taken as a 0, with respect to 0 these are all positive, and with respect to this these are all negative. So, highest negative value is the lithium, strongest reducing agent. And you know, fluorine is the strongest positive value, so it is going to be strongest oxidizing agent. So, from this side to this side, reduction property increases. From this side to this side, oxidation property increases. If you आज ice cream खाया नहीं खाया, okay, I am teaching only chemistry. Anush, where you were not talking, please ask a question. So, this is the fundamental information I just want to give you guys. So, based on this fundamental information, if you want to take this and you can take copper. So as this side reduction properties increases, zinc is a stronger reducing agent as compared to the copper. Clear? And you talk about any metal, copper is a reducing agent and silver is the oxidizing agent. You are revising ionic equilibrium. Ionic equilibrium का session, I think we did it, and yeah, in this one short session में equilibrium नहीं आया था शायद, organic किया ना. Okay, so conclusion from the electrochemical series, fluorine plus 0.287 volts is the strongest oxidizing agent. Okay, and hydrogen is 0.00 volts, मान के चलो, it is taken as a reference, and lithium minus 3.05 volts, it is the strongest reducing agent. And you know, in this scenario, applications of electrochemical series काफ़ी important है, काफ़ी important है, right? अगर कुछ doubt है ना तो बोलना, I am giving you all, I'll be giving you all concepts here. Okay, so the case 1, the relative oxidizing and reducing ability of the elements can be compared between zinc copper couple. So in that Cu2 plus 2 Cu, all S, मान के चलो सबका SRP वैल्यू का है, कॉपर इज प्लस 0.34, जिंकर इज माइनस 0.76, उसमें ऑक्सीडेशन पावर इसका ज़्यादा होगा, इसका कम होगा. And also you see one more important thing, if you take this example and take any two values, sir हमको कैसे पता चलेगा ये सबका values? No need to memorize, in the examination it will be given. Okay, in this version in this version let us take an example here, copper 2 plus system, it has oxidizing power ज़्यादा, इसका zinc का reducing power ज़्यादा है. So if you take two electrodes, mathematically bigger value is going to be a strong oxidizing agent. Cathode, it acts as a cathode. Cathode means it is going to having reducing nature ज़्यादा होगा, oxidizing power ज़्यादा होगा, बस. It's a game of redox reactions you studied in the 11th standard. And two, metal placed lower in the series can displace the metals lie above in the electrochemical series. Bachcho. And example 2 here, when you talk about zinc and copper sulfate, gives us zinc and copper sulfate. So can you store zinc vessel and copper sulfate? Can you store copper vessel, zinc sulfate? Which is possible? Which is possible? Such a logical question, such a logical question. And you cannot store copper sulfate in a zinc pot, but you can store zinc sulfate in a copper pot. Why? Because the E naught value is going to be positive here, is going to be positive. So the reaction takes place. When the reaction takes place, these two are going to react and the pot is going to be dissolved. And for this, E naught value is going to be negative, the reaction do not take place. You can comfortably keep it, and if there is no reaction between the zinc sulfate and the copper metal. Assertion reasoning types questions. Assertion reason type questions are very important based on this Applications of electrochemical series. Applications of electrochemical series. Okay. Any doubt? Anuj, Shashwat, Vani? Okay, moving ahead 3. It helps, electrochemical series helps us, the electrode assemblies to give the galvanic cell or not. If two electrodes are say, the polarity can tell you. I told you the spontaneity of the reaction. When you combine this, E cell is equal to E naught cathode minus E naught of anode. When they couple, if the E cell is positive, the cell reaction आगे बढ़ना है. If not, the E cell value is going to be non-spontaneous. So when two electrodes are combined, you have to say the mathematically bigger value is going to be cathode and the mathematically smaller value is going to be anode. And also reference electrode. We will discuss about this reference electrode. Reference electrode is an electrode. The absolute value of the electrode cannot be measured. By taking the difference between the reference electrode and the electrode values can be measured. The reference electrode we take is a normal hydrogen electrode or standard hydrogen electrode. Hydrogen has a tendency to form hydronium ion as well as hydrate ion. So its value of electronegativity is 2.1 in the middle or the lowest 0.79 of the cesium. Fluorine is the highest. So lowest is cesium, highest is fluorine. So that hydrogen has exactly almost a middle. So at the elemental level, it's a electronegativity is an intrinsic property. At the elemental level, we can do it, right? And so we can construct hydrogen electrode potential. So this is a hydrogen electrode. In this hydrogen electrode, platinum coated, platinum black coated, platinum wire is taken as an electrode, and in that it is immersed in 1 molar HCl, and we pump the hydrogen gas at 1 bar pressure and we maintain 25 degrees centigrade, so that this is the electrode experiencing is going to be 0.00 volt. So the platinum foil, okay, is dipped in acidic solution of 1 molar HCl in which a pure hydrogen is bubbled to 1 bar into the solution, right? बच्चों समझ में आ रहा है क्या? सोनाली? So the platinum surface is coated in such a way that likely to attract H2 gas towards itself, adhere, mean to say absorb on it. Moving ahead, so there will be an equilibrium between hydrogen gas and H plus ions, and at this equilibrium we are going to assume it is going to provide you 0.00 volts electrode potential. And when you write this cell, it represented, a cell can be represented using some universal, convenient and acceptable notations. So rules for this. Rule 1, the separation of two phases should be shown by a single vertical line. I mean to say zinc 2 plus and zinc. So a metal and a solution between these two, a vertical line is given. Copper 2 plus and copper, a vertical line, and two vertical lines indicates it's a salt bridge. And LHS, anode has to be written, RHS, cathode has to be written. Fine. And in this way, you can say zinc 2 plus, copper 2 plus. So phase boundaries are shown here. Any doubt? Phase boundaries are shown. and anodic half cell has to be written in the left side and cathodic half cell has to be written in the right side. अगर कुछ डाउट है ना तो जल्दी पूछना. And a salt bridge is written by using two vertical lines. In some books it is written like this, okay, in some books in a different way, but vertical line is the IUPAC system. And if various materials are present in the same phase, they show together with comma. Like you see, SN2 plus vertical line and SN2 plus SN4 plus a comma. Fine. And here, if the significant figures, the significant features of the substance like pressure and concentration should be written here. So, zinc 2 plus is present at 1 molar, molarity, if the gas is there. So, PT, you can use H2 1 atm. You can use this. इसका pressure भी दिखाना है. So 1 molar it has to be. Okay. And rule 5. For half cell involving a gaseous species, that's what I want to say here, इसका pressure भी दिखाना है. This is a standard notation. PT H2 H plus. So gas and aqueous solution a vertical line. A gas and a solid, it is a vertical line. Hope you are understanding this. Clear? Any doubt? Wonderful. अगर कुछ डाउट है ना तो पूछना जल्दी. Now, let us see complete cell representation. It is PT H2 1 bar H plus aqueous 1 molar copper 2 plus aqueous 1 molar copper solid. In this we use a vertical line. This is a salt bridge. We use a platinum which is an electrode and a vertical line which is indicate phase boundary, and here it is anode, LHS anode. You always memorize this. You always memorize this. LHS vertical line, RHS, and so cathode is written in the left hand side, anode is written in the right hand side. So this is the general representation of the galvanic cell. समझ में आ रही क्या? सोनाली, क्यों डर लग रहा है आपको? क्यों डर लग रहा है बेटा? शाश्वत, are you there? Those who are online, please like the session. हमको अच्छा लगेगा बेटा. जल्दी. हम बच्चों के लिए कुछ भला करने का कोशिश कर रहे हो. आप भी भला करने का कोशिश करो. And you see, a cell consists of copper 2 plus. Half cell is anode and half cell consists of electrode with Cl2 at 1 bar reducing Cl minus. This can be written. So this is verbal format of this. Copper is converted to copper 2 plus and Cl2 bar, and Cl2 gas is 1 bar, Cl minus aqueous 1 molar, and graphite is the electrode. Graphite is the electrode. Copper is the electrode. It is, understand? Any doubt? So, right, when the question comes in this format, you need to understand what it is. So, let us talk about the Nernst equation. We know as the concentration increases or decreases, cell potential also changes. Cell potential depends on the various factors like temperature, composition of the reaction mixture, concentration and the pressure always. So, Nernst equation जैसे equation है, it includes everything, and how this cell potential changes with this. Mostly we take the concentration and the pressure into the consideration for our general calculations. So effect of concentration and the pressure of the gas on the cell potential according to thermodynamics is given as delta G is equal to delta G naught plus RT ln cube, reaction quotient. So minus NF E cell is equal to minus NF E naught cell is equal to 2.303 RT log to the base 10 of cube. R is the reaction quotient. You know, chemical equilibrium, we learn about this, right? And you just take this E cell is equal to Q is equal to, for a reaction मान के चलो A moles of A plus B moles of B gives rise reversible is C moles of C and D moles of D. And reaction quotient is equal to C active mass to the power C, D active mass to the power D upon A active mass to the power A, B active mass to the power B. I mean to say CD product का है and AB reactant का है. So I want to say A, B, R. A is the activity. So you can put this Q in this version and you are going to get directly the Nernst equation. E cell is equal to E naught minus 2.303 RT by NF log Q. R is a gas constant 8.314 and T is the temperature 298 Kelvin. F is the 96,500 coulombs and 8.314 and temperature 298. So some value मिलके n variable होगा. So put that, you going to get this is your Nernst equation, or otherwise you can also say this. And I have a simplest version of this. E cell is equal to E naught cell minus 0.0591 by n log to the base 10 of QC. Fine. And so at equilibrium Kc or Kp is equal to Qc or Qp, then दोनों बराबर भी कर सकते हैं ताकि डेल्टा G value 0 होगा at equilibrium. So that you can also say E naught cell 0 is equal to E naught cell minus 2.303 RT by NF log equilibrium. So that we are coming to the concept of equilibrium. We learned this in the equilibrium. Fine. So you are going to say E naught cell is equal to 2.303 RT by NF log equilibrium constant, and log equilibrium constant is equal to NF by 2.303 E naught. So all the values you put it, log to the base 10 equilibrium constant is equal to N E naught cell by 0.0591, because this is a constant, this is a constant, this is a constant, sub constant मिलके ये value मिला. Or otherwise better, you can use this for shortcut. E cell is equal to E naught cell minus 0.06 by n, okay, log anodic concentration by cathodic concentration. Use this and you can directly get it for any galvanic cell we have, right? Any doubt, bachcho? Any doubt? Now it is a long marathon session, and rest of the points we will be discussing. Already more than 300 questions or 300 slides are there. Okay. So as the time is almost exhausted, अबे आगे session भी लेना है. बच्चों, today we learned directly from the electrode potential, oxidation and reduction, and we ended up to Nernst equation. And this is the part 1 of the one shot series, and the part 2 RX series लेना चाहता हूँ next week, and I will discuss about Faraday's laws, conductivity and applications of Nernst equation. So as the time is almost exhausted, we shall meet with more stuff in the next class. So stay tuned till that, and I request you to please like this session and share with your friends and subscribe to Infinity Lane NEET YouTube channel. Thank you very much. Bye bye. God bless you.